Good morning, sir. This is my presentation about the DC shunt generator with high voltage, low current. So this is the schematic diagram of the DC shunt generator. We have the generated EMF, the resistance of the armature, the resistance of the shunt field parallel with the resistance of the load. So since this is parallel, we conclude that the voltage of the shunt field is equals to the voltage of the load. So we have given that the resistance of the armature is equals to the 0.4 ohms, the resistance of the shunt field is equals to 50 ohms, the current of the shunt field is equals to 5 amperes, and the resistance of the load is equals to 2.5 ohms. So first, we need to get the voltage of the shunt field. So voltage of the shunt field is equals to the current of the shunt field multiplied by the resistance of the shunt field. So we have 5 multiplied by 50, and now we have the voltage of the shunt field is equals to 250 volts. So since voltage of the shunt field is equals to voltage of the load, so we have to get the current of the load. So current of the load is equals to the voltage of the shunt field over the resistance of the load. So 250 over the resistance of the load, which is 2.5. So we have the current of the load with 100 amperes. So by getting the current of the armature, so we have the voltage current in is equals to current out. So since the current of the armature is going to in, and the current of the shunt field and the current of the load is going out, so we have the current of the armature is equals to the current of the shunt field plus the current of the load. So since we have given that the current of the shunt field is 5 amperes, and we have solved the current of the load is equals to 100, so the current of the armature is equals to 105 amperes. So since there is generated EMF, so we have to solve the generated EMF by adding the voltage of the load plus the voltage of the armature. So since current of the armature multiplied by the current of the resistance of the armature, so we have the voltage of the armature. So voltage of the load plus the current of the armature multiplied by the resistance of the armature. So 250 plus 105 multiplied by 0.4. So we have the generated EMF of 292 volts. So since in this circuit there is a resistance, so we have some power losses. So power losses is equals to the squared of the current of the shunt field multiplied by the resistance of the shunt field plus the current of the armature squared multiplied by the resistance of the armature. So we have 5 squared multiplied by 50 plus 105 squared multiplied by 0.4. So we have the power losses, which is 5,660 watts. So since we need to get the power of the load to get the efficiency, so the power of the load is equals to the voltage of the load multiply by the current of the load. So we have 250 times 100, and now we have the power of the load, which is 25 kilowatts. So we need to get the efficiency to know how efficient is our circuit. So we have eta is equals to the power of the load over the power of the load plus the power of the losses. So we have 25,000 over 25,000 plus 5,660. So we have 0.8154. So we need to multiply it by 100. So we can get, now we get the efficiency, which is the 81.54%. So that's for all for my presentation about the DC shunt generator with high voltage, low current.